For our experiment, we looked at how spoilers affect the aerodynamic efficiency of a rally car. Our research question is, how do different spoiler designs affect the drag and downforce of moving cars at various speeds? So spoilers can be seen on many racing cars, such as rally cars, and their main purpose is to keep the car firmly on the ground by generating downforce to counteract any lift the car might endure. However, adding a spoiler to the car also generates more drag, which is not ideal for racing. So we predicted that the spoiler with the best drag to downforce ratio would actually be the best one.
The purpose of our experiment is to find out which spoiler design generates the most amount of downforce with the least amount of drag. Also to identify at what speed using a spoiler is more efficient. Our result would also help identify as which spoiler would be the best to use in a rally car and benefit it the most. We have 3D printed 4 bits. The first bit fits onto the hollow cavity here, which represents no spoiler. The second spoiler is a lip spoiler that most of the BMW uses. The third spoiler here is ideally used in rally cars, and the fourth spoiler is designed to produce most amount of drag.
A 3D model based on a car with a low drag coefficient was 3D printed to simulate a rally car that's racing. Control along with 3 different spoilers were made to see how drag and downforce was influenced by wind speed. The rear of the car was mounted to the wind tunnel's balance, with drag and downforce being measured. Wind speed was increased at 5 meters per second increments, starting at 15 and going up to 30 meters per second. Each set of results was recorded. The experiment was repeated 3 times for each spoiler, and then an average was taken to get an accurate reading. After each set of results was recorded, the spoiler was changed and replaced with another one, and the experiment was repeated for that one.
Cylindrical drilled hole that was created with 3D concept. This hole allows for it to be suspended within the wind tunnel so that it can float, so that the air can flow properly around it. We had to make sure that the size of the hole and the diameter was so snug that it would not make the car spin while it was in motion. Otherwise that will give us impedance results. Using a different type of method to suspend it in the air, as it created more drag for the car, which would cause more impedance results. So by using a different method, perhaps using a way that it formed so both sides can be on a fixed point within the wind tunnel, be a better idea.
For this experiment, we have measured downforce and drag for 3 different spoilers to determine the best conditions for a rally car. For our first spoiler, I had measured close to no difference when there are no spoilers added to the model. The second spoiler has measured the best drag and downforce, which makes it ideal for a rally car. And the third spoiler has measured with the most downforce and drag, which makes it not suitable for a rally car where we require maximum speed and less drag.